Find the roots of the polynomial f of x is equal to x square minus 81. So this is also a polynomial, and it is of the form of f of x is equal to ax square plus bx plus c. That is the standard form of a quadratic function. But the thing is, the middle term, this bx is missing. That's okay. So I'll go ahead and write x square plus the second term is missing, that is 0x minus 81. So now you have it in the standard form of a quadratic function, and you know, in order to find the factors, we'll have to follow one of the known methods. Like I will go use the x method or the box method, or taking out the greatest common factor between the terms, and there are so many different methods, and we are used to this x method, right? So I have my x here, and the sum of the two numbers, what is the sum I have? This is 0, right? 0 is the sum of the two numbers that I'm going to find, and minus 81 is the product. They go here, negative 81 and 0. So I'm in need of two numbers whose addition is 0 and the product is negative 81. As I have here x square minus 81, this is x and x. For my factors, I got the first terms, and I'm looking for the second term, which is going to be a number, right? A constant value. So now let us come back to this thing here, negative 81. I'm looking for a product of 81, but the sum of those two numbers has to be 0. And when do you get a 0 actually? By adding two numbers. Suppose a number a is added to b to give a 0. It tells me that one number is the additive inverse of the other, right? They have to be the opposites. So what are those opposites whose product is 81 with a minus sign, and the sum is 0? It is obvious, right? 81. Both the numbers have to be the same. So 81 is made up of 9 times 9. Both are the same, right? Equal. But to get a 0 here, one number has to be the additive inverse of the other. You see? Negative 9 plus positive 9 gave you a 0. Multiply those two, gives you 81 with a negative sign because of that negative. Therefore, my numbers here are x plus 9 times x minus 9. So those are the factors of this x square minus 81, written as x plus 9 times x minus 9. Now to find those roots, what do? I'll find the zeros of these two factors. X plus 9 is equal to 0. X minus 9 is equal to 0. Solve them. Opposite, right? I have to cancel the 9 here. Subtract 9 on both sides to give you this. Cancel off this 9. So x is equal to negative 9. And in this, add 9 on both sides. So x is equal to positive 9. Right? So my roots are negative 9 comma positive 9. Right? These are the roots. Okay. So let me show you other method. I have formula, right? An identity, in fact, a square minus b square is equal to a plus b times a minus b. That is the difference of squares. Square of the first term minus square of the second term is equal to first term plus second times first minus second. So that x square minus 81. Okay, here I'll write, not on that. 81 is 9 times 9, right? 9 square. So that x square minus 81, I can write it as x square minus 9 square. So this is your a, and that is your b. Alright. Therefore, a plus b means x plus 9 times x minus 9. I got my factors, so zeros, you can get it that way. And much more shorter, let me show you this here. X square, find the zero of that polynomial directly. X square minus, what was that, 81, sorry. X square minus 81 is equal to 0. Isolate x square, so add 81 on both sides, cancels out. 81 on left side, giving you x square is equal to 81. And the inverse operation, x square, opposite of that is square root, taking square root on both sides. What is the square root of x square? This got cancelled. You will end up getting x is equal to square root of 81 is 9. Not only a positive 9, but also negative 9. So my answer is negative 9 comma positive 9. So these are the three methods. You can follow any one of these and do. And the first one is like a standard process, the regular one, and the next two are, one is using that algebraic identity, a square minus b square, and the other one is solving directly, solving for the variable. Okay.